See them gleaming brightly, those snow-kissed mountain tops. Feel them tickling slightly, green grass and soft raindrops.
I'm Anna Maria Lisotti. I'm a high school physics teacher in Italy on the Apennines. This is north of Italy at the boundary with Tuscany. So we are both in the Mediterranean basin, but actually we are a mountain area, and this is a double challenge in the context of climate change. My presentation will be about innovative materials and how they could be part of the solution.
Clouds are slowly passing.
Because the question now is not anymore whether there is climate change going on, there is enough scientific evidence about it. The question is how we are going to cope in our daily lives with this. And we think that a new literacy in terms of what new materials can offer is part of the education of the future citizens. MOM, acronym for Methods of Matter, Future Materials in Science Education, is an European Erasmus Plus project of 4 schools from Italy, Portugal, Ireland and Germany. We are the coordinating school. The project started in 2014 and will end next summer. MOM focused on new materials. One of the often overlapping sections of the materials is dedicated to eco-materials or materials for sustainable society. Fundamentally, the idea is that to be able to exploit the huge potential offered by these materials in terms of energy harvesting, energy saving, water collection, coping with rising temperatures, and so on, first you need to test their chemical and physical properties and get to know very well their characteristics and their behavior. The project has 3 legs: research, didactical innovation, and creativity. Plus, a huge effort is put into dissemination. First, students learn what's going on in cutting-edge research and interact with researchers and scientists. Then they do inquiry-based science in the school lab on the samples, and last but not least, quite new for Italy, they unleash their innovators' potential and creativity in designing new applications for the materials. With regard to the experimental part, this is done both at school and at home, in home labs, as a sort of science flipped classroom. The implementation of low-cost portable sensors with microcontrollers such as Arduino Uno expands in fact the possibilities of students' involvement and offers them the opportunity to do science whenever and wherever they want. Teachers consider one of the major challenges the integration within the curricula. The idea in MOM is to introduce many of the traditional and curricular science and physics topics with a sustainable development perspective, thus embedding with small or no effort climate change education in scientific subjects at high school level. For example, students are asked to evaluate the best fluid vector for solar ether while plotting heating and cooling curves of different salt solutions, or pasteurization of water in crisis or third world sites is tackled through solar ovens, whose design must be implemented by students to get the right temperatures. Greenhouse effect in buildings with large windows could be strongly reduced with thin films for solar control. But on the market there are a lot of films. Are they all effective? Are there any significant differences? This is what the students investigate. Reflectance, emission, absorption, and albedo of surfaces are studied in the context of the urban heat island. Research has proved that cool roofs and cool pavements may reduce the use of air conditioning down to 70%. Whitewashed houses are typical of the South, but actually at the moment on the market you can also find dark paints such as black paints which are cool, Their characteristic is a very high reflectance rate. This can be measured even in a school lab. Regarding creativity parts, students ran a challenge. They asked parents to give in the old lamps and they recycled them, giving them a new life with new materials and new electronics to make them smart lamps. And here are some of the examples. Ask if there is something else except the aesthetic aspect of the lamps built by the students. And actually, for instance, just to take one example, the dichroic glass is used with PV cells. In fact, the two different colors are directed on two different kinds of PV cells, which are more sensitive to one color rather than the other one. With regard to the photoluminescent lamp, then, the application of photoluminescence, for instance, it has been applied with PV cells in combination. So there is in rural street lamps, the main lamp, which is turning on and off with the sensors when people are passing. But then when nobody is around, you just have the dim light of the photoluminescent material, and this is kept working during the night with small shots at intervals from a UV LED, and this way you are saving a lot of light. Finally, a group of students investigated the light concentration properties of fluorescent acrylic sheets, and they recorded an awesome increase in the output of photovoltaic cells located at the sheet edge. Measurement of the concentration led to build a smart concentration PV lamp, which has actually been awarded the participation to Makers Faire Rome 2016, a successful mix of creativity, engineering, physics and coding.
Sing the sign and feel the time has come. The skies above have opened, just flooding all we've got. The fire race has started, the green turned into brown. Isn't too late to slow down. Yes, we can help. It's not in vain, 'cause we can place of our birth. Living, love and breathing, oh Mother Earth. We all stand together for the place of our birth.
MOM is a Teach Us to Teach Us project, enhanced by international networking and by the different pedagogical approaches of the 4 partner schools, combining to produce a rich educational environment. All materials will be published as open educational resources with free download. At the end of the project, August 2017, a summer school on the Apennines in Italy will take place, and it will be open to all interested European teachers. Applications are now actually open.
Live, love and breathe.